System of nonlinear equations in two variables. In this video, we're going to recognize systems of nonlinear equations in two variables. We're also going to solve nonlinear systems by substitution. A system of nonlinear equations are graphs which can consist of circles, parabolas, or any other type of graph except two lines. Now, you can have at least one line, but one of them will be nonlinear. So in this particular example here, notice with the first equation, if you look at out of all the terms, if the highest degree is a squared term, then that is a quadratic equation, which is a parabola. Here, when you notice that you have an x and a y and it's a first degree, that indicates that you have a linear equation. So we have one linear and one nonlinear. When solving these types of systems, it doesn't matter, regardless, whatever solution that you get, it must be a solution to both equations. It can't be a solution to one and not be a solution to the other. So the solution of a system is a set of all such ordered pairs. Solving by substitution. Example 1, solving nonlinear systems by substitution. So hopefully you have already mastered solving linear systems by substitution. This with nonlinears is very similar. Anytime you use substitution method, it's going to be all about taking one of those equations and solve for either x or y, and then plug it into the other equations in that variable's place. Okay, so let's go ahead and begin here. We have the two equations. On the second one, we can go ahead and solve that for either x or y. It will probably be easiest to go ahead and solve for y there, since y has a coefficient there of -1. So let's go ahead and solve equation number 2 for y. So the first step to doing so is I need to move that 3x on the other side. So let's go ahead and subtract 3x from each side. And the variable you're solving for should never be negative. So to make that y a positive, you would have to multiply or divide by -1. And what you do to one, you have to do to all terms. So essentially, you can do that with mental math and simply just change everybody to their opposite, because that's the same as multiplying or dividing by -1. So now we have rewritten our equation solving for y. It would be y equals 3x minus 9. So we're going to take that part that we solved for y, and we're going to plug it into the other equation, the one that we didn't use. So since this equation came from equation number 2, we can't plug it back into equation number 2. We have to plug it into equation number 1. And we're going to plug it in whose place? In x's place or in y's place? Well, we solved for y. So that means we're going to plug it into y's place. So again, substitution method is about first solving for x or y. Take that equation and plug it into the other equation in that variable's place. So there we have removed the y from equation number 1 and replaced it with what we solved for. So now we're going to go ahead and do the distributive property, 2 times 3x and 2 times -9. Next, we want to combine like terms while they're on the same side. So we want to combine that -18 with a +10. That's going to give us -8 there. We're solving for x, so since we have a squared term, a first degree term, and a constant, let's put that together all on one side. which is called the zero factor property. Let's use that property. It means everybody on the left, 0 on the right. So that means I have to subtract 6x and add 8. Once we get everybody on the left and 0 on the right, the zero factor property says that next you're going to factor the trinomial, take each parentheses, and set it equal to 0 and solve for x. So we can do mental math and solve this for x. We can see that we would add 4 and x would equal 4, add 2 and x would equal 2. Okay, so we know now that x is 4 and 2. To find out what y is, we need to plug it back into one of the original equations. But it is always easiest to plug it back into equation number 3. You say, well, I don't see a number 3. So what I mean by equation number 3 is the one that we solved for y at the very beginning. So if I were to give that a name, I would call it equation number 3. But that equation is always going to be the easiest to plug in, because if you look here, it's solved for y. So it means once you plug in to the right side, you will know what y is. Unlike the others, they're not set up that way to where you can easily be able to get your answer. So let's go ahead and plug it back into equation number 3. Starting with the 4, removing the x and replacing it with 4, I'm going to have 12 out front. And 12 take away 9, we see will be 3. So y is 3. Now let's plug it into the 2 in, removing the x and replacing it with 2. That's going to give us a 6. And 6 with a minus 9 is going to give me a negative 3 for y. So we have 2 ordered pair solutions here. We have 4, 3, because of 4 for x, so 3 for y. Here, this was a 2 for x, and we got out a negative 3 for y. So these are our 2 solutions here. Remember, if you're ever unsure about your answer, you can always plug your solution back into the original equations. If when you plug it in, it leaves you with a true statement, that is proof that you have the correct solution, and it must be a solution for both. So in the first equation, if I plug the ordered pair 4, 3 in and do the math, the left side is 16. If we do the math on the right side, we see it's 16 as well, so that checks. That solution works. Let's plug it into equation number 2. If we plug our solution into equation number 2, that same solution of 4, 3, the right side equals 9. Let's do the math on the left side and see if it equals 9. 12 take away 3, it is 9, so that checks out. So this solution is good because it is a solution to both equations. Now we have to try out the 2, negative 3 to make sure it is a solution to both equations. So when we plug that in, we're going to get 4 on the left side. If we do the math on the right side, we can see that it also equals 4. Plugging that same ordered pair into the second equation, the right side equals 9. When we plug in the values on the left side and do the math, we can see that it also equals 9. So as you can see, both solutions check out. Now, you don't have to do this extra step if you are sure about your math along the way. But if you are not certain once you're finished as to whether it is your solution, you can always check by plugging your solution back into the original equation. And here is the graph of the solution. So the points of intersection, the point where they touch, that illustrates your nonlinear systems solution. So our graph intersects or touch at 4, 3 and at 2, negative 3, and that is our solution.